Good morning, good afternoon, and good evening. This is a demo of the DidLang interpreter, version 0.3. It's different from the previous demonstrations in that it will show an example of did agent clusters, load balanced, round robin clusters. But I will start from the beginning. So if you're brand new to DidLang, you'll see examples of all the capabilities it has. So DidLang is a command language um, implemented as a command line interpreter for did identifiers, did documents, did agents, and did objects. This particular interpreter understands one particular method called did color, and it understands 142 different colors. And there's a help system. So you can just type in H or help. And the top level commands, the most common commands are just simply entering a did. And you can see if that did verifies, if it is known and verifiable by the underlying infrastructure. Or you can do star did, which we refer to as indirection. So we can indirect through a did, and if you indirect through a did, of course you expect to receive the did document that's associated with that did identifier. And that's what in fact happens. You can do star star did, that's double indirection. So if you think of single indirection, if it returns a did document, double indirection is we're going to return a agent structured credential. An agent structured credential that's associated with that particular identifier is a structured credential that describes the interfaces that agent has and the methods that each of those interfaces exposes. So taking a step further, star 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 did, or triple indirection, is going to give you the did document. Then it's going to get the default agent's structured credentials, the description of the interfaces and methods exposed by that agent. And then triple star is going to invoke the default method on the default interface. And what do you expect to get back? You actually expect to get an object. You actually expect to get the red object or the green object or the blue object or whatever color out of the palette of 142 colors that the did color method exposes. So let's start with some simple examples. Let's use the did that most people are familiar with, did example colon 1, 2, 3, 4. And what we see here is the parse tree for did colon example colon 1, 2, 3, 4. And these are all the properties that are drawn out of that did. We're not looking up on any verifiable data registry. We're not looking at any did document. This is simply parsing the did colon example colon 1, 2, 3 did identifier. And we can see that it verified false. It verified false because this interpreter only understands the did colon color method name. So let's try something different. Let's try did colon color colon red. More or less what we see before, the did identifiers did colon color colon red, and the top level name is did, and the method name is color, and the ID string is red, and a bunch of other stuff. And we see that it verified true. It verified true because this interpreter actually understands the did colon color method namespace. It does not understand the did colon example method namespace. So let's go another step. Let me clear the screen and do did colon color colon red. But this time we're doing star did colon color colon. We're doing one level of indirection. So instead of simply verifying whether the did is verifiable or not, we go and extract the did document. from the simulated verifiable data registers, simplified simulated VDR. So here we can see the parse tree, and then we see the DID document. Standard, pretty much a standard DID document, authentication service, the public key for the DID document. Um, One thing that's new in this version of the interpreter is its support for clustered service endpoint. So this is a clustered round robin service endpoint. The type of the agent or the type of the software that's running at the end of that service endpoint is something called a Bluetooth tools.agent. And here we see that clustered round robin service endpoint has four different URIs or four different instances of the Bluetooth Tools agent running out there on the internet somewhere. And we'll see examples of how that's used shortly. So clear the screen again. This time let's go 3 levels of indirection. Did, colon, color, colon, red. And here we actually see the red object being returned as a structured credential. So if we scroll up to the top here, we see the object structured credential, the context, the name. We see that in the comments that it's the red, object properties that are being returned from, that third level of indirection. First level is returning the DID document. The second level of indirection is returning the agent description. And then the third one is executing the default method on the default interface on that default agent and returning the properties here. So we see down here in the credential subject that the ID is did colon color colon red. And we see in the claims that the formal name of the color is capital RED. Alpha of 255, red of 255, 00 for the green and blue components. The rest of this are the standard components that you would expect to see in a verifiable credential. This is a special type of verifiable credential called a structured credential. It implies that the ID and the claims are organized in the fashion that you see here, following that structure, that you can have a name property and a comments property, some extensions to the standard verifiable credential. At the bottom, we have a proof. Again, in the simulator, this proof is kind of mocked up, but that's what you'd expect to see in terms of a fully decentralized object being rendered as a verified or structured credential. CLS. So let's look at some other examples. To make things easier, there is escapes using the exclamation or the bang character. So if we type in bang H, we get some helpers. So for example, if you're tired of typing in did colon example colon 1, 2, 3, 4 during your testing, you can just say bang 0, and that's the same as if you typed it in yourself. So we can see bang 0, you see what it is translated to, and we get the same result as before. If I go bang R, we can see that that's the same as did colon color colon red. So if we clear the screen and go bang help, we can see that, bang 1, 2, 3, 4 does single, double, and triple indirection through the color red, did colon color red. We can also see that we've got shortcuts for doing triple indirection based on the name of these three, primary colors. So if we do bang blue, oops, typo. If we type in bang blue, that brings the blue color, of course, with the blue component being 255. At the bottom here, we see some special forms of the top level commands. So bang A here does star star, and then we have this bracket notation. This, if you're familiar with C, C++, C sharp, that's coercion, the coercion syntax. So what we're saying here is in that second level of indirection where you're extracting the description of the agent, its interfaces, and the methods that that interface has. You might want to override both the type of the agent and or the ID of the agent. This is in essence the type of the service endpoint and the ID of the service endpoint. So if I type in bang A and I scroll up to the top, we can see that when that is parsed, we're making more use of the properties in the parse tree. We can see, for example, that the service endpoint is coerced or overridden. And if we go down here to the service endpoint type and the service endpoint ID, we see there the values that were included um, uh, in the coercion. If I do bang B, it's double indirection, two asterisks. And so here we're executing again agent uh, type B, service endpoint type agent type B, and then the ID B to pick the specific service endpoint. If we go bang C, we can see that again it's a slightly more complex variation. So in this variation, we're doing triple indirection and we're overriding the agent interface and the method within the agent interface. So we can see that we have interface method coercion taking place. And if we go down here, we can see that the interface method um, has been overridden and the agent interface has been overridden. We go and extract the did document as before, we extract the agent as before, and then we extract the object. Oops. Um, if we go bang D and scroll up to the top, D is triple indirection. We have three asterisks. Triple indirection and double coercion. We're coercing the agent type ID and the ID. So we're picking a particular agent. And we are also overriding the default interface and the default interface method. So when we go down to the bottom here, tricky getting these to scroll properly, we can see that object, of course, because we're executing that default method, we're always going to get the red object. The interesting addition in this version of the interpreter is bang E, bang E. And when we go up and look at the top there, we'll see that we're overriding the identifier for the service endpoint. So we can override just the service identifier, service endpoint identifier. We don't have to specify the type. The type would normally be for the caret symbol there. And so we can see that the default endpoint type is Bluetooth agent. That's the default. But we've overridden the service endpoint and we can see that it's did color :red cluster agent 2. That's interesting because that is the ID of the clustered service endpoint in the did document. So if we scroll just down here a little bit to the did document and look for red : agent cluster 2, we see that red : did : color red : £sign agent cluster 2 is the ID of the clustered round robin endpoint. And where we see that having an effect is here in the object. We see that this object was executed off the agent round robin index number 1. If we scroll back up here to the agent itself, we'll see that the agent that we've picked is agent round robin index 1. So built into the interpreter is the knowledge of clustered service endpoints, of type round robin, and it actually knows how to perform the round robin indexing. So for example, if we do this again, we see that this came back on round agent round robin index 2. We do it again, index 3. If we do it again, index 0. Why index 0? Because we only have 4 agents that are in our clustered, um, in our cluster, our round robin cluster for the Bluetooth agent. So that's kind of cool. We're starting to get into sort of an enterprise state, an enterprise quality implementation of agents distributed across multiple service endpoints, being able to execute the identical code on each of those service endpoints. So it's in effect, those agents can be running anywhere on any service endpoint. We'll always get the same result back. And pretty cool addition to the interpreter. So you can see at the bottom here of the help screen a description of all the different syntax um, for overriding or coercing the service endpoint type and the service endpoint ID, as well as the service endpoint interface and the service endpoint interface method. One last thing, if we look at the escapes, there is one called colors, which is just shows you all the colors that are supported by the DID::color method space and the names. So, for example, cyan or crimson, you can just type in triple indirection did colon color colon crimson. And we can see that crimson has a lot of red in it, a little bit of green, and a little bit of blue. And that's it. Thank you very much for your time, and look forward to future enhancements of the DID language.